I like surrogate keys. I like logical data models. Can we make this marriage work? Welcome to this video on database normalization. My name is Kevin Fiesel. I'm the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. After recording the final planned video in this series on database normalization, I decided that we needed a coda episode to cover one topic I just couldn't fit into the normal videos. In this video, we are going to talk about surrogate keys and whether they belong in a logical data model. I asked the professor to help explain this topic, but he growled something about winter break and threw an empty whiskey bottle at my head, so we're doing this on our own, people. Hello, class, or, well, empty classroom. Everybody has already cleared out for their break, so it's just us in here. I have made mention of surrogate keys a few times in this series. In case the term is unfamiliar to you, let's briefly explain it. Here's an example of a relvar and a relation at some point in time that we've used a few times now. This relvar has a candidate key. That is, there's some attribute or combination of attributes which guarantees uniqueness for each tuple. In this case, the candidate key is the combination of artist, album, and sales country. This candidate key is also known as a natural key because the attributes already exist in the data model and we do not need to create them separately. Let me contrast that with an example of a surrogate key, which I'll call ID. In this case, I have added an artificial or surrogate key. This key has no business value and only exists in the context of my database. It can serve as a mechanism for guaranteeing uniqueness, but in the logical modeling world, it's a second-class key. We can't rely on a surrogate key to determine uniqueness of a tuple because it doesn't really exist in the data. It's just something we smash in there in post-production with the physical data model. That's an argument I'm willing to accept without too much concern, but it does lead me to a question. Do surrogate keys belong in logical data models? Well, normally the answer is no, they do not belong in logical data models. Surrogate keys certainly can belong in physical data models and in the database itself, but logical data modelers typically think of these as mechanisms of convenience. Let's briefly hit on the different ways we use surrogate keys in the physical data model to help us understand why this is the case. First, surrogate keys tend to be more compact than natural keys. A natural key is oftentimes a string or a combination of strings and maybe some numbers. By contrast, a surrogate key is usually some integer value or maybe a GUID. In either case, you're talking about somewhere between 1 and 16 bytes per tuple versus potentially dozens or hundreds of bytes. Second, surrogate keys allow us to simplify join criteria. If we wanted to join tuples from this relation to tuples from another relation, we would need to include all three natural key attributes on both sides, whereas using a surrogate key means we can join over a single integer value. Third, surrogate keys are static. There is no need for the ID ever to change. By contrast, natural key elements might not be as fixed. During the series, I brought up an example of renaming unnamed future album. Natural keys have a tendency to morph over time. Even in our fifth normal form design, renaming unnamed future album would require updates of multiple tuples on multiple tables, so we could run the risk of missing one or more of these tuples. By contrast, if we introduce a surrogate key for album and propagate it to the other relvars, we make renaming the album a one-step operation. There's no questioning that surrogate keys can bring value for a data modeler, but most of that value is further down the chain. Compactness does not matter for us in the logical data model, as we don't really care about data sizes or how we lay the results out on disk. Simplifying join criteria does not matter for us in the logical data model, as we're not writing SQL statements at that level. And static surrogate keys, they don't really matter either, as we think in terms of relvars at the logical data model level, not relations. So the data itself is kind of irrelevant. That means there's no data to update at the logical level, just the rel vars with headers made up of attributes and data types, and the bodies that will be made up of tuples whose forms match the headers, but whose contents we don't really have to care about right now. That all makes sense and helps explain why logical data models tend not to have surrogate key fields, and why we wait until the physical data model to add them. But along the way, I started thinking about the problem in a bit more depth, and I'm going to take that out on you, dear viewer. I think there's a little bit of a philosophical problem with respect to surrogate keys, and that is, your surrogate key sometimes becomes my natural key. For example, here is a rel var and a sample relation that we saw in the 5NF video. We have in there an attribute called warehouse ID. Is warehouse ID a surrogate key? Well, not for us it isn't. I didn't create this ID, but we instead received it as some natural business indicator of the warehouse. If we originally got this warehouse information from some source system, it's possible that warehouse ID was originally intended as a surrogate key, an information-free database construct intended to uniquely identify a tuple. But surrogate keys have a tendency to leak out. We often use surrogate keys in applications, as warehouse ID 6 is easier to pass back and forth as a parameter versus the warehouse located at 406 9th Avenue. Over time, business users may come to rely on speaking in terms of that surrogate key, providing it some business meaning along the way. Now, I'm willing to say that a surrogate key can never become a natural key in its own database, no matter how much the business side comes to rely on it. We need some other mechanism to identify a thing's uniqueness before we can assign it a surrogate key. So we can't say, because your surrogate keys are unique, therefore you two things are different. I need some mechanism prior to the database, prior to the surrogate key, to indicate what makes a tuple unique. Well, what happens then if we import warehouse data from another system? Does that surrogate key become a natural key for us? I think that answer is a lot tougher, and I can see arguments going both ways. Assuming that the downstream data model is good and its surrogate key does have the backing of some natural key, we now have two ways of identifying the warehouse: its ID and whatever that natural key might be, such as a physical location. Warehouse ID has adopted some measure of business utilization, and it might be safe for us to treat this as a scenario with two natural keys. But now we've linked our logical data model on the assumptions of another data model, and it seems like a troublesome proposition of its own. In practice, we do see this quite often with data warehouses storing information from the source system, including surrogate keys, so we can identify lineage between systems. In that case, if I need to maintain lineage, then these remote surrogate keys are good as, well, at least as good as anything else. But as a general rule, I don't want my relational database model to rely on the correctness of some other relational database model. I want it to stand on its own. That's my hesitation with the idea of converting another system's surrogate keys into some quasi-natural key. And this is all making a big assumption though, and that's the assumption that we're looking at warehouse ID originally as a surrogate key in some other system. Just because there's an ID or an integer doesn't mean it was originally a surrogate key. Organizations generate identifiers quite frequently, and those identifiers have innate business meaning. For example, a bank generates checking account numbers for individual customers' accounts. With the Catalyxy Services business checking account, I have a checkbook with individually numbered checks. When I bill a client, I send out a uniquely numbered invoice. My state legislature generates a series of uniquely numbered bills for each legislative session. These are all cases of numeric identifiers representing individual things, none of which are surrogate keys because they do have innate business value, even if they are auto-incrementing or we had some automated process, including perhaps a database, generate them. Let's bring it all back together. If I'm going to use surrogate keys anyhow, isn't it better to include my own surrogate keys in the logical model from the get-go? The answer to that, I think, is no. Surrogate keys bring no benefit to a logical data model, and they can also fool us into believing that we have a proper key when we really don't. When it comes to using data from other source systems, I am hesitant to include remote surrogate keys in my logical data model, and the reason for that is I have to trust that the source system got it right when it comes to defining what makes a thing unique. If it got it wrong, I'm propagating their logical errors in my system by allowing duplicate results. But if a number, even an auto-incrementing number, has actual business value, it's not a surrogate key, and we should be able to trust it in our logical data model. By the way, class dismissed, or at least it would be if this were a real class. This was a fairly short jaunt into the topic of surrogate keys and remote source systems. We covered surrogate keys a little bit during the series, but I wanted to have this lengthier monologue drive home the point that our logical data model ultimately reflects a business understanding of the data. For that reason, it's important for us to ensure that we don't listen to the siren song of surrogate keys. Instead, we need to be asking the hard questions about what makes a tuple unique. We'll have links and show notes in the description below. And until we see each other in the next video, take care.